Guys, now we are starting into our actual course. Okay, we are starting into our actual course now. So let us see why Apache Kafka. So hope you have seen, you are now able to see my screen, I believe, isn't it? So now let us understand. Before understand the Apache Kafka, we need to understand the events first. Why we need to understand the events? Because if you can see the official definition, as per the Kafka documentation, you can see Apache Kafka is an open source, distributed event streaming platform. Okay, so what is Kafka? It is an open source, distributed event streaming platform. Now you have to understand individually each and every word. What is open source? What is distributed? What is event? What is streaming? What is platform? As part of this, let us start understanding first what is event. Then we will understand what is streaming. Then we will understand what is event streaming. And again, we will understand what is event streaming platform. Okay, got it right? How we will go? So let us go and then first understand what is event. Okay, let's go here. Okay, so assume that we have a retail business. You just consider retail business in the sense DMart or Reliance store or more market or whatever it is. You just consider one retail business. If we consider retail business, we will do the orders, the orders we may return, or the orders whatever we placed will be shipped to our address, right? So this is retail online business. Retail business can be an online, retail business can be. Are you providing recording of the class also? Yes, today's recording is also provided for you guys. Okay, please keep your questions and then ask me at the end of the session, guys, because if you ask your questions now, maybe I will lose my concentration because my opinion, because you came here, my first priority is you. So I have to give the answer for you. When I'll give the answer, the others will get deviate, isn't it? So keep your questions with you. Just allow me some time. I definitely will have a time with you to clearing all your doubts and all. Okay, fine, right? Just allow me some time. Perfect. Okay, let us now understanding what is event, because in the Kafka documentation they said Apache Kafka is an open source, distributed event streaming, open source, distributed event streaming platform. So now we need to understand what is event. Okay, let us try to understand what is event. I believe my slides are visible to you, right? Right. So let me just increase it. Yeah, hope you are now able to see it. Okay, so we have assumed that we have a retail business. Okay, in the retail business, maybe retail online or retail offline, right? For example, Amazon is what? Retail online. DMart is what? Retail online. Sorry, DMart is what? Retail offline. So we have the retail business in the sense, maybe it is offline, maybe it is online. In case if it is an online or in case if it is an offline, either of the case, first, whatever the products we have purchased, we need to order first. At least they will prepare the order copy, isn't it? When you go to DMart store, you have purchased a grocery for the month, and what they will give you? They will give you the invoice. That means what? Before creating the invoice, they will first place an order. They will scan all the items, and then first they will prepare an order copy. Okay, then that order copy will be placed for the payment. So you will do the payment, then you will get an invoice. So first order, then payment, then invoice, isn't it? Then by showing that invoice will be 2 copies. One is with them, one is with you. So whatever with you, then you can showcase it at the gate of the DMart and then come out. That's it. Then you will be end with your shopping, isn't it? Similarly, if you want to return any item, for example, you purchased one tube light and it is not working when you came to home and then test it. Then what you will do? You'll go and then you will return it. isn't it? Or else, in the DMart, you might have purchased one TV you purchased, assume, or maybe in the Reliance store, you went to Reliance store and then you purchased one home theater. What they will do? They will ship that home theater to you, right? First, you have to make the payment. Before making the payment, they will first create it as an order, and then they will ask you to pay the payment. Once you've done the payment, they will give you the invoice, and with that invoice, they will start the shipment. And the same invoice you have to showcase when they will deliver the item at your doorstep, isn't it? So this is what a retail business case. Same in the case of the banking as well, like service request, stock tickets, trade transactions. So everything, service request, everything is an operation, isn't it? So assume that we have a retail business. The business performs many activities. However, every business activity is played by an actor. Actor here in the sense, maybe a person who is at the POS system, point of sale system in the retail store, like in the DMart, counters are there. In the counters, there were the persons are there. Those persons are called as the actors, right? Or maybe that actor sometimes may be another system as well, right? So an actor is a real life person or a machine or an automated process, whatever it is. So the action performed by an actor generates an event. So what you will do? Basically, what you will do? You will go to the billing counter. Okay, you will go to billing counter and you will showcase your products, what you have purchased. Then this person will scan each and every product, right? And then this person will place an order, creates an order. She will create an order. And then as part of the order procurement, she will ask you to do the payment. When you do the payment, then an invoice copy will come to you. That invoice copy contains what? Data of all your products, what you have purchased, right? What you have purchased, the item, the quantity, and then the price. So all this information there in the invoice. Now, for example, invoicing is a business activity performed by a point of sale operator. Okay, so please look at this business activity. So this is the business activity. Now, if you can see, now we can see. So the POS operator is the actor. She will create the invoice. That means what? POS operator is the actor. She will do an action, and as an outcome, we will get an event. So what we understood now, event is the outcome of the action performed by an actor, right? Event is the outcome of an action performed by an actor, right? Now you got the event. Now you got the meaning of the event. Event is an outcome of an action performed by an actor. Actor may be a POS operator, actor may be another system, actor may be an automated system, whatever it is. But if it will do some action, for example, you are paying the course fee. Let us say you might have scanned it, right? And then you done your payment. As an outcome, what is happening? As an outcome, you will getting the invoice. That invoice you are sharing with the DurgaSoft, isn't it? So what you have done, you performed some action. What is that action? Transferring the money or paying the money. So some action you have done. As an outcome of that action, you got an event, isn't it? That event is what? The invoice. Invoice got generated for you. That invoice, when you share to the DurgaSoft team, then they're going to give you the access to the classrooms, isn't it? So event is an action. Event is an outcome performed by an action performed by the actor. Now, these events, let's say this event, now we understood, right? The event is nothing but, in our case, invoice we have seen. So what that invoice contains? Invoice contains the data. Invoice contains what? Data. The invoice copy contains what? Data. Data of the items what you have been purchased. So whatever the products you have purchased, those products information were there in the invoice. So event contains what now? Data. This is very, very important. Please focus. Like in our example, the invoice is an event which we got as an outcome once you do the payment. And that invoice copy contains what? All the order items, meaning data. So event contains what? Data. Now let us see. As we know the event, the next step is to capture the event data as the data object, right? So this event data, meaning the invoice copy contains the data of all your items, all the items you have purchased. So this data capturing is very, very important. Why this data capturing is very, very important? Maybe this data, that means the invoice copy, they will send to shipping team so that the shipping team will start shipping your smart TV. So what they have given to the shipping team, the event, meaning the invoice copy in our example, that is nothing but what? Event, which contains the data nothing but the product or the items what have been purchased. So what we can understand now? So we can understand event is the data object. Event is the data object. So here, capturing the invoice event as a data object is a simple and creating a JSON object for the invoice. So whatever the printed copy we got it right from the printed copy we got from the demand POS systems, right? That printed copy data may be saving as a JSON data or maybe some other data in their database systems or some other systems. But the point here is when we do the payment, we got the invoice. So when we performed an action, we got the event. So event is nothing but an outcome of the action performed. And that event contains what? The data. That's it. So that's it, right? I think it is clear for everyone. Okay. Event is data. Again, you guys are asking crazy questions for me. Event is data, na? Event is not action. Event is the data. Invoice is what? Invoice is nothing but event you consider. Is that an action? No, invoice is what? Data. What is the action here? The POS operator who is placing the order and then asking you to do the payment, right? That is called as an action. So as an outcome of that action, you got the event. That means the that means the invoice you got. Now assume the case. This is very simple case, but assume the case. So as we capture the event, the next step is transport the event. So that means what? We got the invoice receipt. Now this invoice receipt should have to be sent to the various teams, like shipment team required to take one invoice. Then reward points team, loyalty and then reward points team should have to take your invoice, because next time they will give you the discounts on the loyalty points you have been added with, isn't it? So likewise, the event, whatever we have captured as part of an action of doing the payment for the product you have been purchased, that event should have to be transport now across the multiple systems, meaning multiple applications. So whatever events we identify, they are likely to be generated continuously. This is one example. Likewise, in one town, for example, you consider Hyderabad, we have 100 plus DMart stores, and consider all over India, we may have thousands of DMart stores, right? In thousands of DMart stores, for every second, for every millisecond, or for every second, or for every minute, these events are happening continuously, meaning people are purchasing the products and then the invoices are generating for every minute, every second probably. That means event is happening every minute, every second, right? So maybe within the time gap, the events are happening. Not at all the same time, maybe same time or maybe a fraction of seconds gap, but that time gap we can ignore. But the point here is what? These events, whatever are happening, may be happening multiple, one after the other, or maybe at a time multiple events are happening, right? So whatever the events we identify, they are likely to be generated continuously over a time as a series of events, because You purchased in the same DMart store, you may have a 10-15 counters. You purchased one item, other purchased other items. A lot of people purchased more, many items. Each and every person's is doing the payment, and for them the invoice copy is generating. That means events are happening there. So in one store, many events are happening. Likewise, we have the many stores, many events may be happened, isn't it? Please carefully catch the point here. Very important this is. Okay, in one DMart store, not only you, there are many members are purchasing. In a day, lakhs of transactions are happening. In a day, lakhs of transactions are happening. In a day, lakhs of events are producing. In a second, in a minute, overall the India, maybe lakhs of invoices are generating, right? Now the problem is what? There is one problem here. Carefully observe, please. So, okay. So whatever the events we identify, they are likely to be generated continuously over a time as a series of events. These events are produced one after the other, maybe concurrently, maybe, right? We are not sure, but the events are producing continuously. So for our previous example, the invoicing is not a one-time activity. The operator keeps generating the invoices one after the other. For example, if you take one operator, that operator will keep on generating the invoices one after the other. Once you've done your payment, then the queue, the person will be in the queue, will come to do the payment. Again, once that person done, then the other person who is behind the person will come to the queue. Like one POS operator, if you can take, one POS operator can generate multiple events one after the other, right? Likewise, in one DMart store, many of the POS systems, many of the POS operators, many POS operators will generate many events, many invoices. That is only in one store. Consider a city where it is having hundreds of stores. Considering the country where we have thousands of stores. So thousands of stores, lakhs of events are generating per a minute or per a second over a period of time. You just consider, right? So this series of events is what we term as a stream of events. You got it now? The series of events, the series of events, meaning the events generating one after the other continuously, is called as what? Stream of events. Stream of events. Now we connected, we understood what is event. Now we understood now what is event stream, right? Got it now? You got the event and you got the event stream. Okay, now let us get into a few of the problems, what the problems we have here in real time. Okay, so here POS actor, one POS operator can generate a many stream of events over the period of time. I think you are following me or not, I'm not sure, but please carefully observe the things. Event meaning outcome of an action that contains what? Data. So in one DMart store, many events are generating. One POS operator is generating many events. The series of events called as event stream or stream of events. The series of events generating are called as stream of events. Excellent. Excellent. Now let us go and then see the, how we can transport these series of events now, right? So we have the series of events, and these series of events are generating in a time gap, right? So now the stream of events is a natural phenomenon of the business. Any business you can take, it is a natural phenomenon. Stream of events should be happened. For every transaction, one event should be generated, and the stream of events should be happened. For every business, it is common phenomenon, right? So all we need to do is now how we can transport these events, multiple events generated to many systems, right? So now we have to think about transporting the events. Hope you are able to see my screen and it is visible, I believe, right? So here is the POS system, and we have a shipment service, we have an analytics service. So whatever the payment we made, we got the invoice, and that invoice maybe need to send to shipment service to ship the product to your doorstep, and should be give to analytics service to have the analytics or the reports or the customer data with the particular retail store. Okay, now how we can transport the event among the many systems or many applications? That is the biggest challenge for us now. Okay, so how do we transport these events from the place of origin to the place where we want to process them? Right? How do we transport these events? So transporting events from one place to another place is a common requirement. So if we take the microservices architecture, we create a bunch of sample applications. So each taking care of a specific responsibility. Forget about the microservices architecture now. You may be confused, but you just consider only the retail store, right? So the below screenshot, this screenshot is showing us the invoice event that is generated at the POS is need to be sent to shipment service. And this shipment service would be interested in scheduling the shipment of the items in the invoice. So whatever the items in the invoice, this team will ship the items. And similarly, the analytics service would also need to know about the invoice event and take into account for analyzing the sales pattern. Weekly they are purchasing or monthly they are purchasing, or what items they are purchasing, just to analyze the sales pattern. This say analytics service also requires the invoice. Perfect, right? Now the problem is how we can transport this event. Okay, how we can transport this event. Okay, now as we know that event as a data object, right? Event contains the data, meaning invoice contains the data. So consider it as an event contains the data. So as we know that event as the data object, which we want to move those JSON objects from the place where they are generated to the location where they need to be processed. So from here to here, we need to transport the event. Okay, so this transportation requirement appears to be a one-to-one relationship. That means here the POS system, one POS machine to, we need to transport the event, meaning the invoice, whatever the invoice generated from this machine, we need to transport to shipment. And from here, we need to transport to analytics. So when we think about from this POS, it is one POS which need to send the invoice to one POS which need to send the invoice to many services. So this is one to many, if you can see from the one POS point of view. Okay. However, if you can see the shipment service point of view, the shipment service will get the invoice from the many POS, and analytics service will get the invoice from the many POS. In a demand, we have the 15 counters, right? So from the counter 1, the shipment service will get the data. Counter 2, it will get the data. Counter 3, it will get the data. Counter 4, it will get the data, meaning invoice. So one shipment service will get the data from the many POS machines. So when we think about the shipment service and then analytics service, it is many to one. When we think about this POS, it is one to many. Now let us understand this with the clear picture. Okay, this is the original problem statement now we got. Okay, so how to transport it now? I think you are following me, right? Please let me know if you need a break for 5 minutes or 10 minutes. I definitely will do that, because continuous listening is also a problem, but we will lose the, that flow if we take the break. That is the reason I'm not giving any breaks. Please follow. Now, one POS system, second POS system, third POS system. Likewise, we have the many POS systems. These are all POS systems. We call it as the event producers, right? Event producers. Now, these event producers will produce the invoices to the inventory, analytics, loyalty, shipment, finance, data lake. So these are all the services. For them, these events will be produced by the producers. Now, these are all the services, right? Shipment service, finance, loyalty, inventory. These are all called now consumers, because they are getting the data from these POS machines and they are consuming that data. Here, each and every operation is called as, here if you can see, one thing is calling, sending the data to one POS is sending the data to data lake. The same POS is sending the data to analytics. Same POS is sending the data to inventory. See these blue lines, you carefully observe blue lines. and this POS is sending the data to shipment and then finance. Similarly, this orange one, sending the data to data lake, analytics, inventory, loyalty, shipment, and then finance. Likewise, many POS machines will send the data or event to many services, many other services. It is a many to many. It is a many to many, right? So assume there are many POS systems in our store. If we have a multi-store business, they are spread across the stores. So if we are accepting online orders, then from the online also we'll get the invoices. Now, if you can see here, there is no single destination. There are many destinations where the POS machines have to send the invoice copy. Not only one destination, not only inventory, not only loyalty, not only shipment. There are many places where these POS machines need to send the data, right? So the invoice is required by the finance, shipment, inventory, planning, loyalty, analytics, and data lake, long-term storage, and many more systems. So how do we solve that many-to-many streaming requirement, right? So from the many producers to the many consumers, how do we stream the events? Again, stream of events, nothing but what? The events generating one after the other over a period of time is called as what? Stream of events. So those stream of events, how we can distribute or how we can send from the many POS terminals to the many consumers, like inventory, analytics, shipment, loyalty, finance, data lake. For the many other services, how we can transport the event, right? So that is the problem. Now you got the problem, right? So as soon as you do the billing at the DMart POS counter, point of sale counter, you will get one invoice. That invoice immediately should have to be sent to all these departments: analytics department, store department, loyalty department, shipment department, finance department. For all these departments, the invoice copy should have to be sent. So you are only the one customer. You maybe purchased only one product or maybe multiple products, but you will have only one invoice. So that invoice need to be sent to many of the departments. So throughout the day, not only you, right? Many members will purchase, many invoices will be generated, and many invoices should have to be sent to many departments. Now, how these invoices will be sent? Continuously. Because just in a minute, in a second, overall the India in the DMart store, in a second, in a minute, just think about how many purchases are happening. So all these are what? Invoices generating, invoices sending to all these departments. So how it should be happened continuously, right? So how we can solve the problem of sending the invoice copy to all these departments continuously? So each connection here, if you can see, each connection, whatever this retail machine having the connection to these backend applications or the departments, each connection between the source and destination is a stream now. Okay, here you guys, please understand carefully. This is very, very important point. The sentence itself is very, very important sentence. Okay, please focus. What it is saying is, I think if you understood whatever I'm discussing so far, if you understood, this is easy for you to understand. Each connection between the source POS machine and to the destination departments is a stream. What does it mean? What does it mean? From a single POS system to the many departments, continuously invoices will be sent one after the other. That is nothing but this sentence meaning is. So each connection between a source and destination becomes a stream, obviously, because from the one machine to the various departments, continuously the invoices need to be sent one after the other, because the customers are there for the DMart store and the customers will keep on purchase the products all over the India. Then obviously each and every POS machine should have to be continuously in touch or connection with the all other departments applications. It is practically impossible, right? It is practically impossible for the POS machine. It is practically impossible for the POS machine to send the invoices to 20 different services continuously. Practically impossible, guys. In 1 minute or maybe another time or one another time, the POS machine will get the issues, connectivity issues, network issues, right? Maybe these consumers also, consumer applications also may be down at that moment, right? Now, here is the actual problem starts. Please focus more. Actual problem starts here. Okay, just to take 2 minutes of break. At least I'll go for the water and then come back. 2 minutes of break. 11:09 it is. 11:11 I'll be back because the actual problem is starting now. Okay, so just give me 2 minutes. I'll be back. Thanks a lot, guys. I'm back. Okay, now the actual problem is starting. What is that actual problem? So in the DMart stores, not only in the DMart store, you can take any retail store, the POS machines continuously sending data to the other systems. It is practically impossible. Definitely we will get the connectivity issues, we'll get the internet issues, or POS machine problems, or maybe the application problems, so many issues. Now the actual problem arises. A customer purchased a product and the invoice copy is sending to the shipment service. Okay, while sending it to the shipment service, assume the shipment service is down. Okay, shipment service is down at this moment, but this is continuously sending the data. So now after exactly 2 to 3 minutes, shipment service is back. Now the shipment service is taking the data. Let's say this is sending message 1, invoice 1, invoice 2, invoice 3, invoice 4. Shipment service got broken down and then come back after 2 minutes. At that moment, this is sending the invoice number 8, invoice number 10, invoice number 9. So this shipment service is only receiving invoice number 8, invoice number 9, invoice number 10. Now, what about the invoice number 5, 6, 7, 8, or at least 5, 6, 7? Customers paid the amount, customers went to home, customers maybe expect the item will be delivered to you within the some period of time. But the shipment department is not received the invoice copy. 1 week gone, 2 weeks gone, 3 weeks gone. Customers will do what? Start complaining. They have not received the product. Now assume they went and then checked the POS side, POS sent the invoice. Checked the shipment side, shipment not received the invoice. Then where that invoice will gone? Where that invoice was gone? Right? Right? Continuously sending, where that invoice was gone now. So these problems we may get. So how do we solve this kind of problems now? Okay, shall we go as a database as an alternate to this one? Meaning, can we use database to solve this problem? Okay, so let us try to evaluate the database as an alternate. The below screenshot shows a possible solution for the given problem using a database. Let's say this POS system will send the invoice copy to the database stored in it, and then from the database, shipment service is getting it. let's say invoice is sending. Let's say POS system is sending invoice 1, invoice 2, invoice 3, invoice 4, 10 invoices. Then the shipment service is taking the invoice 1, invoice 2, invoice 3, 10 invoices. Let's say shipment service is gone after 4 invoices and came back after 2 minutes. Then shipment service will still have the storage of the invoice 5, invoice 6, invoice 7, invoice 8, invoice 9, invoice 10. So this is primarily solving the problem of the data losses, what we discussed in our earlier screen, right? So this is now solving the problem. If you have the database, this is solving the problem, correct? But now here one more problem is there. If you use the database, what is the problem? Let us see. So we can place a database in between and simplify the many-to-many relationship. Putting a database simplifies it to a many-to-one from the perspective of the event producers. Event producers, one event producer or one POS machine sending many POSs to this database. Likewise, it is a one POS machine, many POSs, many invoices sending to the database. So it is one to many. So from the perspective of the event producers, it is many to one, meaning many invoices are sending to one database. Please note this point. Okay, carefully observe this point. Here, one POS machine is sending many invoices to many invoices. It is sending to one database system. It is many to one now. So if we just look at a producer, it is merely a one-to-one relation with each producer. So here, if you think about the producer wise, not the event wise, many events are reaching to one database. One producer is sending the many events to one database, right? So similarly, one to many, if you look at the event consumer side. So consumer is receiving many events from one database. And it is also one-to-one, meaning one consumer is receiving the data from one database. Assume. Okay, here that is not the important one. The important one is what? Database solved the problem of the data loss here. But here is one problem we have. Let us see what is that problem is. Okay. So we look at an individual consumer, then this is fine. The event producers such as POS terminals and our online web store, they're all persist the JSON object into a database. Let's say this is MongoDB or let's say DynamoDB. So each and every POS machine is storing the invoice as a JSON object into this database. Consider the event consumers such as finance, shipment, inventory, planning, loyalty services. These are all other side of the database, right? So other side of the database, these are all consumers to the database and then taking the data from the databases. So they merely consume those events from the database. Here, event meaning data, event meaning object. Object contains the data. So we already have seen invoice is what? A paper. Invoice is a paper that contains all your items purchased. But what that paper contains? Data. That data is storing into the DP in a JSON object. And that data, nothing but the event, is taken by these shipment, analytics, and many other department services, right? So the producers and the consumers are now decoupled using this database. Earlier, producers are consuming or directly connected together. We call it as a stream, but there is a chances of having the data losses. So if we place the database in the middle, then what happened? When the database is in the middle, this database decoupled the consumers and then the producers. And we do not have a direct connection between the producers and then the consumers. So this solution appears to be good alternative for the data losing problem what we have discussed. But here we have one more challenge. Okay, what is that challenge? We can use the database, of course, but database is solving the data losses. But here is one problem we have. So what is that problem? Let's go and then see the problem. Challenges with the database. So using database table to design a stream of events could be a tricky solution because database table does not naturally represent stream of events. This statement is very, very important. So please make a concentration on this statement. Database table does not naturally represent, say, stream of events. Why? We will conclude in a couple of slides, in couple of discussion. Okay, now consider one scenario where the database is not suitable for the stream of events. Consider one scenario. A typical database system records every insert and update transaction into a log file. Do you know this? Every database is internally maintaining a log file. So database is nothing but a file system only. On the machine, database is nothing but a file system only. Okay, I think I can showcase even that as well. But maybe database is storing the data in the files only, internally. Okay, whoever attended my Docker and then Kubernetes, they might have imagined this one, right? So they might have imagined this one. So just database is storing the data in the file system. Okay, now database is storing the log entries in the log file. Okay, now here you can see the problem is the logging is necessary for the database to handle the failures. So it will log the data. However, the tables are the aggregated and mutable materialized. This you can't understand now. Let me explain. Here you can see. Let me increase little. Yeah, now you can see here. So this is invoice number DAMB 509, which is inserting the invoice into the DB. Okay, which is inserting the invoice into the DB. Now this is another invoice number DAMB 708, which is also creating into the DB. Yes, two are created. DAMB 708, DAMB 509, two are created. Okay, how many events? 2 events produced from the POS machine. This is for one customer invoice. This is another customer invoice. Later, what happened? The customer returned one item. Customer returned one item. And customer want to get the money by returning that item. Then the update, the POS operator or maybe the DMart store, the person who is taking the return items, right? That guy have taken the invoice and then updated the invoice by minusing one item. Okay, that is also one event happened, right? Updating is also one event, right? Creating the invoice is one event. Updating is also one event, isn't it? Clear, na? Updating is also one event. But if you can see this, how many events are happened now? 3 events. 2 new invoices are created. 1 already created invoice is updated. But in the DB, how many records we will have? 2 records only, right? So whatever DAMB initially have the price 3953, that now the price as 3133 because 2 items or 3 items were removed. They want the money returned back. So they return the items in the DMart store and then they have taken the money back. So now the invoice is updated with the 3113. But here you can observe how many actions performed. 3 actions performed. Invoice created for one customer, invoice created for another customer, again invoice is updated for one customer. 3 actions are performed. But in the database, how many invoices we have, right? So we have only the updated one, right? So now it is losing one event specific data. So this can be resolved actually. Programmatically, this can be resolved. The history, we can maintain one history table or we can maintain one audit table. But that is what programmatically you have to do a lot of coding to achieve that. For example, as if you are all the Java developers, you might know the hybrid inverse concept, history and concept, right? So you use that, then you will enable the auditing. So maybe you will create an history table and that history, the history will be maintained. But how much coding you have to do for that? There are 2 to 3 joining. Again, the joining will eat your performance because it is inheritance concept of one-to-one relations. Definitely eat your performance. Okay, we can handle it. So we can handle it. This problem can be handled. But that problem, if we can handle, it is not a big deal to handle. But if you handle that problem, we have to write a lot of code changes, right? So that is the reason we are saying database table does not naturally represent a stream. It is not suitable for the stream, because a stream can be a create operation. Stream can be an update operation. Stream in the sense, series of events, series of invoices will be generated. Invoices may be new payments. Invoices may be updated, meaning few members will return their items and then update the invoice. In the case of updating in the database, we don't have the evidence of the operation happened. So here it will show created by the operator 1, but later it will show updated by the operator 2. So we are losing the history who created this invoice. We only have the data who updated it for system. So this is the problem with the database. However, we can handle it. You can take one more table called history, and whatever the data operation here, you can dump into there. You can handle it, but think about the performance. Lakhs of data it is producing. Events are generating per minute, per second. Lakhs of events are generating per minute, per second, right? So those lakhs of records it is generating, storing lakhs of records in 2 or 3 tables is good practice? 100% no, because the performance will be severely get affected, right? Maybe it is NoSQL as well. You can see MongoDB. Sir, I will use MongoDB. I don't want to use, the RDBMS. Yes, you can use MongoDB as well. Or sir, I will use the DynamoDB, which is stretchable, extendable, right? Durable. Yes, you can use it. But the problem is what here? We might lose the auditing and then history information if we go with such databases, right? So these are the problems that we have with the database. Yes. So this is what? Hence, instead of using a database table, we want to evaluate something that naturally represents an event stream. What is that? Interesting. What is that? That is nothing but Kafka. That is nothing but Kafka. So this is again information about database log files. And so we can use the Kafka there, right? Hope everyone now connected, right? Kafka. Perfect. Now what is Kafka? So Apache Kafka takes the same idea of representing the event stream using the immutable log entries. Here we have to understand this concept, immutable log entries. Database, what happened? Database table record, invoice is created. Then whoever updated invoice, the same record is updated. That means it is a mutable log entry. Database is maintaining the mutable log entries. That is the reason the same record we are able to update it. Whatever the record we created, that record is able to update because that is a mutable record. So Kafka doesn't maintain that. Kafka maintains everything as a new. Either it is new record, a new invoice, or updated invoice, everything is a new entry for it, right? So now Kafka will represent a stream of events using immutable log entries. It won't update the entry what it have created in the log file. Rather, it will create a new entry for whatever the events it is getting. So if we take the earlier solution and replace the database system with Apache Kafka, then we can see the system like this. Now we have the Kafka, and Kafka will keep on store the data into these log entries, log files, right? And every data is a new, every event is a new record here. 100% we will have the track of all the records, right? So that is what the Kafka comes and then solve the problem. Okay, in Kafka, Kafka implements the log files and sits in the center of the streaming infrastructure, right? The producers, meaning the POS machines, sends the events, meaning the invoices, to the Kafka. Kafka persists those events into the log file, and the event consumers are on the other side. They read those events from the Kafka and then process it. So these events, these events will be read from the Kafka by these consumers. Kafka internally will store the events in a log file, right? So here again, infrastructure wise also we have little issues in maintaining these log files, but we have the solutions as well. So the solution delivers the benefits such as decoupling of producers and consumers as well, and simplifying the many-to-many relationships. Now, any number of events can continuously stream to this Kafka. Kafka will store everything in the log directory or log file, and then Kafka using from the Kafka, the consumers will get the data continuously. Now there is no data losing, there is no mutable records, everything is immutable here, right? And it is storing the data directly in the file systems. Definitely it is lightweight compared to the databases. So this is what the Kafka is. That's all, guys. Now you understood what is Kafka. Sorry, not what is Kafka. Why Apache Kafka is what you have understood now. Okay. Now let's see what is Kafka. How many kinds of Kafka installations available in the market now? Okay. Kafka is a open source. Okay. I have to say Apache Kafka is an open source. So Kafka is a distributed event streaming platform. Now we understood what is event, what is streaming. So Kafka is building a platform which can handles the lot of events, and then which will delivers the lot of events to other services. So it will infrastructure of the Kafka or the Kafka installation architecture, we call it as a streaming platform. However, I'll again discuss about this Kafka platform and all in our coming up sessions. But what is Kafka now? Why Kafka you understood? What is Kafka now? So Kafka is distributed event streaming platform. Why? It is distributing the events, stream of the events it is distributing, right? For the many systems, meaning many applications. To do that, it have a sophisticated platform. Platform in the sense, it's have its own architecture, cluster architecture. I'll explain that. Now, how many types of Kafka installations we have? So I want to give you the clarity here. So we, in the market, we have the two kinds of the Kafka you can see. One is Apache Kafka. Second one is Confluence Kafka. So what is this Apache Kafka? It's an open source, free Apache 2.0 licensed version. It is completely open source. And again, coming to this Confluent Kafka, we have two options. One is community version. Second one is enterprise version. So community version have, again, completely free. Community version is completely free, but the enterprise version is not free. So we will use the Apache Kafka for our part 1, and we will use the Confluent Kafka for our part 2. Confluent Kafka community edition we will see for the part 2. Okay. Now the differences between the Apache Kafka and then Confluent Kafka we'll discuss in our coming up sessions when we really start the installation. That's all, guys, from my side. Now let us start the question hours. Do you have any questions for me? I see a lot of questions, right?
Yeah, sir. I have one doubt, sir.
Yeah.
So I don't know before this session, I don't know anything about this Kafka. And in previous sites, you mentioned the Spring Boot is a requirement. So can you just put some light, like what concepts in a Spring Boot we must know before starting this Kafka?
Okay, not all the concepts actually. Okay, just let me showcase something now. As the question asked, let me showcase something now. Okay, just let me go to One moment, guys. Just let me go here. Source code. Okay, I just would like to showcase if so we have the 3 Spring Boot applications. We call them as microservices even. So movie tickets generator, movie tickets validator, movie tickets consumer. So what we have to know here, about the Spring Boot application structure, Spring Boot starters, and basically how the Spring Boot will work. If you know that, well and good. And actually, I would like to say one more thing also. The part 1, whatever I have shown, the part 1 course content, right? This entire part 1, we will execute on complete command line. Complete command line. So we will learn the Kafka concepts using the complete command line utility. Then whatever the concepts we learn, we just apply it for the Spring Boot application and then microservices. So if you want to learn, though you don't know my Spring Boot microservices, if you want to still learn the concepts, yes, you can still learn the concepts. And whatever the technology you know, implement it on them. It's not a big deal. Okay, so I have taken the Spring Boot and microservices as they are in the market, and then the interview questions are there. How to integrate Kafka with the Spring Boot microservices, what are the use cases, right? So that's how I have taken this one. Got it?
Yes. I just have last question, sir. As you just demonstrated that the Kafka is solving that problem. Maybe I am wrong, sir, but I have this question. Can we use SNS there?
Obviously, SMS also we can use, but the problem is what, your question is 100% absolutely correct question, but we need to understand about messaging system. That is our next topic. So in next topic, we will see point to point and then pubs and subs model. So point to point, meaning messaging system with the point to point, we have one limitation, and pubs and subs, we have one limitation. So I'll discuss those limitations. And that's the reason we'll go for the Kafka. Even Kafka is also a kind of pubs and subs model only. Kafka is also using the messaging system, meaning Kafka is also a messaging system architecture one. So, but it will solve the problem that were there with the ActiveMQ, RabbitMQ. It will solve that problem. Okay, they are just messaging brokers, but Kafka is more than that. Kafka is not just a messaging broker. Kafka is event streaming platform. There's a lot of meaning for that. Okay, in our next sessions, I'll discuss about this one.
Sir, I have 2 questions.
Wherever we are using this ActiveMQ, RabbitMQ, we can use.
If it is required, if your project have the streaming capacity, meaning if your project have the streaming requirement, use Kafka. Of course, for example, RabbitMQ you have taken. So RabbitMQ is not really, clustered environment. Then you will go for the ActiveMQ. So ActiveMQ, again, you will take the Zookeeper and then ActiveMQ instances. But the data that is storing in the ActiveMQ is in-memory database. Again, it is kind of H2DB. Again, your database problems will arise. So that is the reason we are going for this Kafka. So problem is 2 things here. Point number 1, if it is just messaging delivery, go with the any of the messaging systems. It is not only the messaging delivery, it is streaming also. Heavy infrastructure or continuous here streaming, meaning what, two situations, guys. Point number 1, messaging meaning what, for example, when the user is created, an email should have to be sent. So that email we can send and then store in the message broker like RabbitMQ, ActiveMQ, and then we can send it, we can deliver it to the consumers, like, your inboxes. How frequently it will be happen? Maybe, very less time. But comparing to this POS use case, every minute, every second, continuously data flow is there. If that is the case, then go for the Kafka. Well, business demands have in the continuous events generation, continuous events consumption, go for the Kafka. If occasional events, occasional messages, don't go for Kafka. Go for the message brokers. Am I answered? Got it right?
Understood, sir.
Yes.
And-
And moreover, if you compare to RabbitMQ, Kafka is distributed, right?
Exactly. Kafka is distributed. RabbitMQ is not distributed. That's the problem. Yeah.
Yeah.
Sir, when we say distributed, what exactly it means, sir? It means like it is communicating with the multiple systems, right?
Which one you're talking about? Distributed?
Yes, sir. When we say something like we just say na, that the Kafka is distributed, then what exactly
correct.
it means, sir?
Okay. The point is what here. In order to answer that, first we need to know about this P2P, point to point, and then point to end, or maybe publisher subscriber mechanism. So RabbitMQ will deliver one message at a time to the one consumer. Of course, there may be more than consumers. Again, in the RabbitMQ, there were mechanisms. If the message is consumed by one person or one service, the message may not be available to the other person. For example, your Ola ride booking, Uber ride booking. What will happen? It might, when you book the ride, it will go to all the drivers surrounding your location. Whoever accepts the booking, then the booking won't be visible to other drivers. That means what? The consumer, the Ola auto driver, accepted the booking and then taken the event. So the event has been deleted from the queue. So the other persons don't see that, isn't it? So this is what point to point. Okay. So this is one consumer, one producer. Of course, it is sprinkling the data to many consumers, but if one consumer will take the data, then the data won't be available. So this is called as, there is one term actually, yes, message persistency, transient message persistency. We'll discuss, guys, actually, when we come to this discussion, we'll discuss, but the answer for the question is RabbitMQ is not distributed in the sense RabbitMQ will distribute the messages to the many consumers. That is fine. But if any of the consumer will take out the message, that message won't be available to other consumers. So hence we can say it is only point-to-point distribution, not pubs and subs distribution. And RabbitMQ is not supporting the cluster architecture. Okay. To have the cluster architecture with the messaging broker, we have to go for the ActiveMQ. So if we go to the ActiveMQ, then we have two solutions. One is, once the consumer receives the message, delete the message. Or there are mechanisms actually, fan out and the persist, or the type of the messaging model we can choose. Assume if the message need to be in the broker itself, even though the consumer consumed it, then how long it need to be kept it, right? So it will be kept forever if we don't remove it. That is the problem with the ActiveMQ. So auto flush out concept was not there. So when comparing, there were a lot of concepts will come, guys. But the only answer, meaning as for your question, my answer is what? Yes, RabbitMQ is not supporting the cluster, whereas Kafka is supporting the cluster. Point number one. RabbitMQ is P2P, Kafka is pubs and subs. Point number two. RabbitMQ can also be used as pubs and subs, but the data persistency into the broker can't get automatically deleted. Whereas in the Kafka, the message persisted will be deleted automatically after 7 days. So these are all the finite differences between these two. Got it? Hope I answered right.